Welcome to Study Loop.
So let's start by making a free body diagram for the skier at this point. So we know that the downward force is mg, and then there's also a normal force, and the sum of these two forces should be equal to the centripetal force. So we can actually say that mg minus Fn is equal to mv squared over r. But then we know that at the highest point, the skier just loses contact with the snow at the crest of the second hill. What that means is that at the top of the crest of the second hill, the Fn will be 0, which gives me mg is equal to mv squared over r. And if I solve that equation for v, that comes out to be equal to under root square root of rg, and r is 36, g is 9.8, take the square root, so that comes out to be 18.0 meter per second. So what we do know is that at this point the speed is equal to 18.0 meter per second. And now we can go back to the top of the first hill, and we are told that the initial velocity there is 0, because it says that the skier starts from rest at the top of a hill. And now we can apply the law of conservation of energy, which says K naught initial plus P naught initial is equal to K final plus PE final. So the sum of initial kinetic energy and final sum of initial kinetic and potential energy equals the sum of final kinetic and potential energy. So we have 1/2 mv naught squared plus mgh is equal to 1/2 m times 18 squared plus 0. We can take the potential energy at the end point to be 0 because that's lower by amount h from the first point. So we can cross out all the m's, and we can now substitute our values. Actually 1/2 mv naught squared will be 0. So we have gh is equal to 1/2 times 18 squared. Substitute g is equal to 9.8, solve for h. The answer comes out to be 18.0 meter per second.